Hello student, in this video I am going to talk about or discuss about another diagramming technique, that is state chart diagram. In this type of diagram, in the analyst or any project person define different states of an object during its lifetime. So here actually we try to define the state of an object. And states are defined as a condition in which an object exists and it changes when some event is triggered. So whatever the behavior object possess or whatever the behavior object shows, that can be plotted or that can be drawn using this state chart diagram. These states are changed by events. So events, or that events will be triggered. So the most important purpose of a state chart diagram is to model lifetime of an object from creation to termination. So we'll try to draw a state chart diagram of any object from creation to termination. So state chart diagrams are useful to model reactive systems. Means what? That type of system where reactive components are there. Reactive systems can be defined as a system that responds to external or internal events. State chart diagram describes the flow of control from one state to another state. So purpose is to following are the main purpose of using state chart diagrams to model dynamic aspects of a system, to model lifetime of a reactive system, to describe different states of an object during its lifetime, define a state machine to model states of an object. So how to draw state charts? Before drawing a state chart program, we must have clarified the following points. We need to identify important objects that need to be analyzed or that need to be drawn. We need to identify those objects. Then we need to identify the states of those objects which have been identified to be analyzed. Then also we need to identify those events due to which that object will change its states. So we'll start with a initial state like this symbol. This is dot and arrow. This shows the starting point of the state chart diagram. That is where the activity starts. A state represents a condition of a modeled entity for which some action is performed. The state is indicated by using rectangle with rounded corners and contains compartments. Then there will be transition. It is indicated by arrow. Transition is indicated by arrow. Transition is a relationship between two states which indicates that an object in the first state will enter the second state and perform certain specified actions. And the final state, the end of the state diagram, is represented by a solid circle surrounded by a circle. This is the end state or final state. Small circle, solid circle is surrounded by a another circle. Then this is a final state. This is a event or action. This is a state where this is the rounded rectangle having the compartments. So this is an example state chart diagram of an order management system. So initial, this is start, initial state, idle, initially this is idle or initial state of the object, initial state. Then it will change its event upon the intermediate. This is the intermediate state. Send order request. Due to this event, that object will change its normal ideal state. That is what it's saying, state will be changed. Then select normal or special order, that is action. This is the next action. Okay, this is normal exit, transition from one state to another state. Then confirm order event, order confirmation, dispatch the order, complete the transaction here. And these states, send order request, if there is anything wrong happens in that situation, it will go for a abnormal exit. That is final state, because this is solid and surrounded by another circle. That is final state. This is initial state, and this is normal exit. This is abnormal exit. Abnormal exit, that is why for any abnormal or error, if everything is okay, then it will go in that way. It will go in that way, and it will go finally and the transition. So that is just these arrow marks, these marks are to understand what is going on, but mainly this is the part of the object, or this is how the object will change its states. So when to use state search? So the main uses can be described as to model object state of a system, to model reactive system. Reactive system consists of reactive objects, to identify events responsible for state changes, and forward and reverse engineering. We can do forward and reverse engineering when we have the StateChart diagram. Again, this is another example. Suppose your ATM card starts at this position. ATM is reading the card not readable, display the card is not readable, and ejecting the card, and it will go to the end of the end state. But if card read is successful, then card is reading the pin that is you are going to enter, and cancel pressed if the at this time the user press the cancel option, it will go again and ejecting the card option. But if the pin is read successfully, it will go for choosing transaction. But again at that point also it is cancel the choose transaction, and then performing transaction include transactions. So transaction is chosen, customers to do another thing, then it will go for choosing transaction, another transaction. At that time also it might choose different transactions, but if the transaction is finished, then customer is finished and eject the card, and might be aborted due to too many invalid pins cards, like that. So in that situation it will go to directly this ending position. So this is the scenario of StateChart diagram. These are the is initial start, ending state, initial state. These are the events of the objects, and these are the transitions. That is, it was showing that transition state, initial state, and final state. So this is simple enough to understand. So this is all about in case of StateChart diagram. Try to go for more this type of example in internet. If you have anything, if you find anything tough to understand, then let me know. We'll try to resolve that over Google Meet. Okay, so that's it in this video. I'll check if there is anything left to describe or to mention about any other diagram remains in the text or context of system analysis and design. I'll try to put another video. So that's it for today. Thank you.